Hello, dear students. Welcome to the lecture 7 of Artificial Intelligence and Machine Learning course. So this week we will continue from our previous lectures. At the lecture 6, we were developing a real machine learning software that will classify our real world data. We were using neural networks basically, and last time we were using backpropagation learning. So today I will copy paste our methods and compose a new software that will have a proper save and load methods as well, and it will be better coded. So from this lectures code, you can do many other you can utilize many other classification algorithms as well. You can expand this software. Okay, so I'm going to compose a new software and I will open a console application again. Okay. So okay, lecture 7, and let's name it as neural networks. However, with the same approach, you can utilize other algorithms as well, such as support vector machines, KNN, decision trees, and such, by using Accord.NET framework. Okay, so we were using these ones. I'm going to install them to our new lecture project. Okay, we are installing Accord and Accord Machine Learning here. Okay, let's wait for previous install to complete. I think it is done. And there is Accord Neuro, which is here. Okay. So I think I will make this VPF software rather than console application. So I'm going to compose another project. I will delete the previous one, by the way. Just don't save it. Okay, VPF.NET Core. Okay, so when the video was paused, I composed the VPF project as here, and I'm going to add the packages to our fresh project by manage NuGet packages. Okay, it is same as console application. Okay. Okay, so the packages are installed. What we are going to do is we will generate our data with copy pasting from here. So let's add a button and do the basic thing first. Okay. Okay, so the name will be BTN build model. So first we need to build our model. Okay. And let's compose the click event. Okay, and let's open our previous projects debug folder so we can copy paste the data. Okay, there's abalone data and iris data, and okay, these two should be fine. Let's copy and paste it to our debug folder of the new project. Okay, it is not generated yet, so I'm going to click build. Okay, here the debug folder. It is still building, by the way. Okay, build is done, the data is there. So what we were doing, we were reading the data and shuffling it each time when we build our model. So we can use the same approach, or for consistency we can remove the shuffle, which I am going to do. Okay, this doesn't have to be static anymore, but they can be static, it is fine. So this will remove the shuffling. Okay, and output classes like this, I will organize them better. Okay, we were using number format info, and with this way we were generating the data, and our latest algorithm was like this. Okay, so there were two outputs we were testing, and the correct output was, let's add the libraries first. And we had a method here, calculate accuracy. Okay, so input and output was correct way to calculate. Okay, output. Okay, so we weren't using the output 2. I'm going to delete it. It wasn't the correct way. And there is learning rate, sigmoid function, backpropagation, quantum. Okay, and calculate accuracy. Okay, since we won't have anymore the console output, therefore I am going to add a label to display our software status. Okay, like this, and let's make it even bigger. Okay, I'm going to name it as status 1. Message switch. Okay, dispatcher. Okay, since this is static, it can't access the dispatcher. I think it should be able to. Okay, now invoke. Okay, equal to SR message. Okay, and we have our label message, and one message, and let's make it by so currently we are doing the basic setup of our software. This means that it will update the label once every 100 iteration, and therefore it will be a more performance way. By the way, so I'm going to put all of them into a if to increase the performance. Okay, so I have written this code because I will be working with threads and tasks. Therefore, from subthread, you cannot update the user interface. You can't access the elements of another thread. Therefore, I will be using dispatcher. Dispatcher is used to do things on the user interface, and I am going to take all of this into a method, so I can call it with a simple method call. Okay, let's say build training model, and I will start it with task factory. So it will be multi-threading. It can be multi-threading, and it won't freeze our user interface. Okay, so this is the syntax of task factory. By the way, I am explaining how to use how to do programming in C# on our YouTube channel. If you are interested in C#, you can watch the videos here. I haven't uploaded the lecture 6 lecture 7 yet, but I will do so. Watch introduction to programming and object-oriented programming. You will learn a lot about how to do programming in C#. So with this task factory, I will be able to start another thread, or let's say task that will run in another thread, and it won't freeze our user interface. Okay, let's start new. Okay, now when we launch and run our application, we should see the same result as our previous lecture. By the way, I will also convert our application to 64-bit to get better performance. Let me do that as well. And when you convert your application to 64-bit, the debug folder also decomposed. Therefore, you have to copy and paste in the data to there. Okay, so okay, now it's 64, and when I click run, I am copying and pasting data to new folder here, as you can see. Okay. Okay, it says there are errors. Oh. It appears that we are getting hit the limit of folder size. Folder name length. Therefore, what can we do? Okay, this is a bit problem. Okay, to solve that problem, I think I'm going to do this. I'm going to remove the path here, remove the name, and perhaps, okay, it should work now. So we were getting folder name length problem. In Windows, maximum length of a file path is 260 characters. Therefore, we were getting an error. Now I have shortened the name by changing the name of the folder. Now it should work. Okay, do we got any other errors? Okay, it has started, and let's click the build model. Okay, so it has quickly run to the completion with 96 accuracy. Of course, we didn't kept the previous records, so we don't know. We can improve our model immediately by saving the best value. What I mean is, so I will keep the maximum accuracy and save it. Okay, so let's make it like this. Of course, this will slow down the application. However, since it is iris data, it is already too fast. And I'm going to, let's make it like, so the accuracy is returning a string. I need I also need a double value, or just make it return a double value. Okay, okay. So I will save the model if it is the maximum accuracy. How am I going to do that is mean value, and if the new accuracy is bigger than the previous accuracy, I'm going to save the model. How can I save the model? It is like the teacher. Okay, there is no saving the teacher. So yeah, probably I can save the network, I think. Yeah, network can be saved. Okay, so save, and save takes stream and file name. Okay, fine. So in this case, we need to define some data so that we can change them quickly. SR model save name equal to iris model and text. I think it should work. And or let's make it we should also save the maximum accuracy as model properties, model prop. Okay, so for model properties, I am going to compose the properties like it is all about saving. To do that, I will use oh, I don't need to use JSON. So I will prepare a string from the network. Let's say parties, and we'll take model accuracy. Okay, and it will also take activation network, and it will take the learning, which is in this case backpropagation learning. It is hard to do for each one. Okay, yes, let's make it for backpropagation learning. And string model SR properties. And we can also take the iteration. Okay, append line dollar iteration equal to top and accuracy percent, and append line, so it will be learning model equal to backpropagation and what values it has? It has learning rate, and what else there is that we can say? Momentum, and there is network information. For the network, okay, this is all cosmetic changes. Okay, activation network, and from network, which data we can get? We can get the layers count, perhaps. I'm not sure. Okay, to get the activation network, I think I will save the activation network as it is, and backpropagation network as it is as well. Activation function inputs counts, neurons counts. Okay. Okay, let's debug and see what we can save. And so that we will know it. Okay, and this is going to take accuracy and the network tree, PP teacher, and the I. Okay, so I'm going to put a breakpoint here, run the application. Why I am doing this? With this approach, I can run multiple tests and see which one is producing the best result. And okay, in the network, okay, there is inputs count and layers. Okay, probably I can use layers count as well, and there is output. So I can get the layer count, input count, and yeah, no other information. And there is activation function, but probably I can't give it here. To be able to give that activation function, I have to define it differently. Okay. Perhaps we can keep them as separate data and directly save them like this. Let me show you what I mean. So string equal to sigmoid function, and there is also alpha. Perhaps I just save it entirely with JSON after all. I'm going to use Newtons of JSON to save the entire network at the beginning so that I can get the name. And so you see I am converting everything to dynamic approach. Okay, Newtons of JSON was Newtons of JSON. Evet. So with Newtons of JSON serialized, I can save an entire object into a file with a human readable format like this, which I am going to do. Okay, prop name, model network. Okay, so it will be much easier now and more dynamic. What I am going to do is I will just save the network serialized object and network data and file.save. Of course, there's no file.save, and the path will be sr network details, or let's make it as SR network details path, so it will be more understandable. Model properties path and model save path. Yes. And okay, so let's rename this as well. Data set path. By the way, since this had some references, I'm going to rename it. Okay, and okay, now it should work. Okay, like this. And backpropagation. I will also save the teacher. Okay, and let's add also teacher save path as teacher details path teacher. It is still pretty messy. We will even more refactor it. So here's data and teacher details path. Okay, we have saved teacher SR. Okay, model properties, model save path, and here, yeah, we don't need this anymore, so okay, this should be enough. I'm going to remove this and this. Okay, save model and SR model properties path and S properties so string. Okay, we have composed our methods and I'm going to remove these now. Okay, so let's run our application. It may run a bit slower right now. Because we will calculate the accuracy at each iteration. By the way, I'm going to add something else here. So better readability and okay. With this approach, I can simultaneously, let's say, train multiple models. Okay. So now it is slower because we are calculating the accuracy at each iteration. And something else maybe. Okay, it is getting even slower because we have made an error here. It will be like this. Therefore, it was saving the model every time. So I'm going to delete this. All right, let's run it again. It will be much faster now. It should save the model and properties whenever we found better accuracy. Okay. So this is the accuracy of training set right now. The model. This is not a proper way, by the way, because we are not using a n-fold cross validation at the moment. Okay, interestingly, we couldn't reach a better accuracy so far. Let's see our so far accuracy. Yeah, this is the best. This is the network, by the way, as you can see. Input const. This is the network object, save. So the network object have all of these inside, which activation function, alpha, random generator, and such. There is properties, still same. And this is the teacher, so learning rate, momentum. And there is the model. Okay, model is not text, it is probably binary or something. Okay, this time we couldn't get higher accuracy, and the reason is, I don't know, let's find the reason. Interesting. Okay, the reason is obvious because this is supposed to be executed at every iteration, because this is what train the model. Okay, run epoch, runs learning epoch. The method runs one learning epoch by calling backpropagation learning run method for each vector provided in the input array, returns summary learning error for the epoch, and it improves our model. That is why it wasn't working correctly. Yeah, now we are getting much better accuracy. Let's see our best accuracy. Okay, so our best accuracy is 97.67 right now. If it gets higher than that, it will be automatically saved, because we save it whenever it gets the best. Okay, I will take a pause for now. Okay, so the iterations has finished, and we have trained the model with 2 million iterations, and the best accuracy has been reached at the 100,000 iteration, and the accuracy is 99.33 accuracy, and over the iris data. However, this is more like overfitting and memorization. Okay, why is that? Because we have tested the model with the data it has seen. Okay, so what else we can do to see the model real accuracy on unseen data? I am going to split the data into test and training set, and then train the model on training set and do the testing. So this is the proper way. Okay, so to do that, first we will split our data and compose new data, and we will use only certain data as training and do the certain data as testing, and test data will not be used in training, therefore it will be an unseen data. Okay, then to do that, let's first split our data as let's say uh, test and training. Okay, let's add a button to do that. Okay, and name. Yeah, I will split the iris data. Or split data. And the class index, we have to also provide class index to be able to split. Okay. Okay, and the data separator. Okay. And so, okay, one moment. Okay, so we are going to split our data permanently to test it. Let's say training, testing. I will use a dictionary to do that, to separate the data. And there will be a class and the data lines itself, so it will be list. All okay. Okay. Okay, so it will read the file name, then okay, list ink. Okay. List if this always contains key Split data, class index, or let's make it like this. We can also add percent. Let's make it double percent. Or integer percent, it can also work. Separation percent. Mm, all right, so then we will shuffle the data like this. Okay, there we are shuffling it by like this. Okay. And we will get top percent of each class. So it will be like this. Count test element count will be equal to plus here percent over 100. So we will make it like this list. Yeah, I can make it like this. Let's range. Okay, and 0 and in a test element count. Okay, this should work. And okay, and list. Okay, from all values, remove where I am going to use a link queue. By the way, if your data is too big, you may get out of RAM memory error. However, I am ignoring that for now. So here I am removing the test data. And then I'm going to save it like this. Okay, file write all lines as yeah, it should work from our model. Okay, once I run this application, you will understand what I am doing. Okay, and this will be the test values. Okay, let's run the application and see the result. You can also go line by line execution with using debug, and however this should work. I didn't call this method, so I'm going to call it here. So the class index is 0, 1, 2, 3, 4. Okay, 4, and the separator is this one and percent 10. So the 10% of the data will be separated from the all data set as testing data. Okay, and I am getting 10% of every class. Okay, so I am building a balanced set. Okay, so this is the training set. Let's open the training set. Okay, training set has exactly 135 elements. And let's open the testing set. So the testing set has 5 elements. You see 5 elements from class 1, 5 elements from class 3, and 5 elements from class 2. So now I can use training set for training and test set for testing to see actual data performance. Okay, so I'm going to change the dataset path. And how am I going to do that is yeah, I will just copy and paste it for easiness. So let's open the original data. Okay, I'm going to move this to original data, and I'm going to copy this to training data, and let's retrain our dataset. By the way, I am still training incorrectly. I am not using K and K-fold cross validation in training. Therefore, I am still like memorizing. Okay, it is still overfitting. However, we will see how much accuracy we can get and how will our model will behave on our test data. Right now, I didn't provide my test data to the training data, so only this data is provided to the algorithm. So the test data, this one, is not trained in the model. Therefore, this is completely unseen data to our training model, and we will see the real accuracy of our model. Okay, this is the accuracy of the training model, and it is more likely overfitting and memorizing because we are not using K and cross validation methodology. We are just providing all data to the training and testing all the data against the trained model. Therefore, this is more likely overfitting and memorization, not generalization. You see, our aim in machine learning is generalization. So much generalization that it can correctly predict the unseen data, it can correctly predict the future data, and future data is what we are looking for, not the existing data. Okay. Okay, let's see our model accuracy. Okay, so it is 99%, 99.26%. It has reached this accuracy at the 64,000 30 389. Okay, it will run until 2000, 2 million iteration, 2 million epochs. And we will test our model with the unseen data and we will see our accuracy. Okay, how we are going to do that, I will show you. Okay. Okay, so the compute method is actually the prediction. So it takes an input. An input is jagged array. Therefore, this is an vectorial representation of a value. I will show you what I mean and you will understand better. Okay. Okay, probably it won't get better. Okay, so I'm going to stop the algorithm, or I can run it without debugging mode, and meanwhile it is working, we can continue our programming and it will be also faster. Okay, let it run. Yeah, anyway. Okay, so let's compose our prediction. Okay, I'm going to make it. Let's just remove it. I'm going to clone this button. Okay, it's cloned. Okay, so name will be btn test unseen data. test unseen data. Okay. And for testing unseen data, we have to compose our network, because we will call this as a method. Okay, this time we will just read the data here. I'm just doing copy paste at the moment, however it can be written better. Okay, so data path will be this one. All of these can be written in a better approach. So testing iris data. Okay. You should never do copy paste in your programming. However, for faster approach, I'm showing. So this will be loaded as input and output. Then we will load our network, which will be like this. I will show you. So let's compose an activation network. Okay, save it. Save it. Model will be from text function input count and neuron count. Okay. Okay. Mm. Okay, there is load, as I guessed. It takes stream or file name. Nice. Okay, so our model was this. I'm loading it. Okay. It returns a network. Returns instance of a network class with all properties initialized from, and we are getting an error. Okay, Accord Neural Network to Accord Neural Activation Network. Hmm. Okay, it says you cannot implicitly. What if we make like this? Okay, let's try this. I hope it will work. Okay, okay, it is still running. And then we will just call our accuracy, calculate accuracy, and we can also modify this to return guesses. Okay, so to return guesses, I will just provide this list, and to get the guessed classes, let's say this string, let's see classes, and I will let it null by default. Okay, so if it is by default null, equal to null. I will initialize it so I won't get errors. And to get the guessed classes, okay, I will make it like this. So the guessed class will be equal to biggest index of the output value and input output LSD guessed classes. Okay, I will debug and see the meaning. Okay, it is still running. Let's equal to calculate accuracy. And let's provide network. Let's provide input. By the way, normally you wouldn't know the output of the testing data, but for calculating accuracy we know it. And do we need anything else? No, because I am still in the testing. Okay, I think this is enough. And here, let's see the output values. Okay, so input is oh, it is null. Why is that? This is interesting. Let's check it here. It is null for a reason. Oh, because we didn't assign input and output. That is why. You see, when you do copy paste, you may miss like this. Okay, now we should have the correct number of input and output. I have all copy and pasted the code. I should have written that as a method. However, we are trying to code it fast right now. So refactoring of code is something else. Okay, now input is there and 6, 2.24 and 1. Let's check it from our testing data. Okay, 6, 2.241. Let's check the last one. 4.7, 3.2. And let's check it if it is correct or not. Okay, it's true. Then we have calculated the output. So output is calculated like this. Okay, this is the output of the input I, by the way. So first input So the output of first input is class, yeah, it will be class 0 probably. So the classes um, were coming from okay. I think I should keep the class value somewhere else to correctly understand that. How can I do that? I can do it. Yeah, here LSD output classes. So these output classes need to be provided to the accuracy data as well. These classes could have been a string, but you would likely to convert them into the doubles for better processing. Okay, I will provide this as well. And so the biggest index will be the guessed class. Okay, add and biggest index. Okay, so this will be the guessed class. Okay, and now I was calling this here. So I will provide output classes as well, which is here already. And okay. And I will also provide another list. Okay. Yeah, let's make it this double as well. By the way, if our classes were not being double, we could have keep them on a book to convert them back. Anyway, I am working with double classes. Okay. Then I can write the result like this. Okay, and let's also write the real output class. Okay, so the output is here at output, and okay. So with this way, I am going to write the index of the test data, the real class of the test data, and the predicted class of the test data. So we will get the every value. Let's say testing or unseen data test results. Okay, let's run the application and see how much accuracy we will get on unseen test data. Okay. Okay, the application has run. I'm going to open the, oh, not this one. Okay, here. Okay, so the accuracy is 100%, which means our trained model has predicted exactly as it is. Okay, so our trained model has reached 100 data accuracy. And what if we make it 50-50? So we will make the training set percent lower and testing set higher. To do that, first I have to copy the original data, or I can make it like this. 1 second. I'm going to say original data, and yeah, let's recompose, and then we can copy and paste. Okay, let's change the percent to 50%. So it will be 50% training and 50% testing. That means we will have lesser data for training. Therefore, the strength of our model may decrease. Oh, since I have changed it to original data. Oh, not this. I see, yeah. Okay, now it should work. Okay, new split is done. Let's check it. So this will have 75. Yes, 75. Okay, and let's check the training. Okay, 72. Oh, this is weird. This should also have 75. Testing and training. Interesting. And let's check the original data. Why it is being like this? Okay, 50 elements and 0 and 50, 50, 50. Okay, 25 elements it will get. Okay, 25 and okay, 50. Let's continue. 25, 50 and 100. So there may be duplicate data which may cause this. I'm not sure. Okay, 150 and 75 and yeah, probably this data set has some duplicate data. Let's check it out. Okay, it didn't show me how many were duplicate. Yeah, 3 lines were duplicate. Okay, anyway, it is fine. It is fine. And then we will copy and paste this testing data to our debug folder and we will start new training. Oh, we have just okay, it should be fine. Okay, building model on the new training data which has only 72 data. Okay, on training dataset we have reached 100 accuracy. Therefore, I am going to close the application and now we will do our testing and we will see how well our model will let's say predict the unseen data, and we have the it. Okay, you see now our accuracy has fallen. Okay, here it has incorrectly predicted and probably this is the only one. Yeah, only one test data has been incorrectly predicted and it is pretty good, which means our model is pretty successful. It didn't memorize And however, this data set is pretty low. I will take a pause and we will continue. Okay, so what is left in our algorithm is having n-fold cross-validation. To do that, we just need to simply modify this method such as this one. I'm going to copy and paste this so it will remain. So the modified method will return an accuracy as double. Let's make it as tuple. Double and a network. Okay. And what it is going to take is simply training model and testing accuracy on another thing. So it will get training file name, testing file name. So there will be input training. I'm going to rename this. And this will be renamed as output testing. Okay. And this will be like, let's remove this. Okay, and output classes. Okay. So this will read it from here and also here. So we will read it. And also we will have input. This will be output training as well. And yes, and there will be also input testing and output testing. Okay. Okay, and okay, let's remove this to here, and I am just copy pasting this for test as well. So this is training file name, and okay, this will generate training file, and this will generate testing file. Okay, this time we will replace this as input testing, and this will be output testing and output testing. All right, you can organize all of this to better, but I am just doing a simple solution right now. We don't use this anywhere, I believe. Yes, we can remove this. This learning rate is also not used anywhere. I'm going to remove this as well. Okay, so when testing the accuracy, this time we will use different input and output. Okay, this will be testing training, and test input testing. It was like testing. Yeah, input testing. Testing and output testing. Testing. So basically we will train model as usual here, and for calculating the accuracy we will use the testing data, and this time we will save the best accuracy. Okay, and for saving I think we should save it temporarily and we will return it. So for saving temporarily, I think I will generate something like this. So the file names will be different. Okay, I will save them into temporary files. Okay, it's working. Temp model savings. Temp model path will be equal to plus from the training file name. Okay, plus of course text. And when saving the model, here we were saving it somewhere here. I will use this temp. We don't need this at the moment. However, we can use it as well. So save model properties. Equal to null. Equal to path. Okay, so this time we will provide it a path as model path. Path, okay. Here. Okay, so this time instead of using a label update, I will use a list box. Okay, and let's set this list box as like this. This is not important. Just to see that. Okay, and I'm going to generate another method for listbox. Okay. Box. Insert 0 and the message. Okay, and now I can use this as well. Okay, currently I am programming it for a multi-threaded programming, because we will train model as many as the number of k number in KNN model. And instead of updating the label so frequently, it was somewhere here. Okay, I will update it once every 1000. So this time it will be listbox. Okay, and I will change the message as testing file name. T. Okay, and BP learning. Zero. Okay, and finally we will return the model and the properties. And for properties, I'll just return a string. Okay, and return new tuple, which will have accuracy. Accuracy will be here somewhere. Yes, max accuracy. And item 2 is somewhere here. Which is the network here. And the string will be file with all text sr prop path. Okay. Okay, and let's add a new button for build model KNN. So the difference of this will be it will split data into the KNN for the n number that we are setting. Okay. And we will provide the file names. So basically it will read the iris data. Let's first regenerate iris data with 90 and 10%. Okay, my computer is being somewhat slow. Okay, let's start it. So I will regenerate the iris data we will use testing and training data. then I will generate the best model by using KNN with 10. Oh, it didn't run. Why? Oh, okay. Let's split the data. Let's continue. Okay, and our training data is here. Copy paste it. Okay. Okay, now we can code our KNN model here. And so basically, directory, create directory, KNN test training. KNN testing. Int IRK number equal to 10. Okay, maybe there is some ready method. I mean cross validation. Why I am writing like this? End fault. Okay, we have all written this incorrectly. Let me fix that. I'm confused. Hmm. And here, okay, I have fixed the naming problem. Okay, and I will just use the iris data at the moment to list. I think it was pretty simple somewhere here. Okay, here. Yeah, check it array. Chunk size easy by 0. I think I can use this string array. Yeah, this should work. Yeah, I need chunk size equal to count over number. Okay, and chunk size, and all data. Okay, chunks will be added as arrays. Then what I'm going to do is simply, okay, count and file write all lines. Okay, so yeah, I have to make it like this. I don't need this. Let's make it. It will be better. You see, I am at each loop I will be generating new list. This is the easy way, but lame way we can think about that. So it will start from 0 and 0 if I equal not mm. So if it is not equal to I, it will be test data at range and chunks and else it will be training at range. So at each loop, one piece will be set for testing and one piece will be set for training. Let me show you what I mean by running. It is so simple actually. If you don't understand it at the first watching, you can watch it again. Okay, so yeah. Now I am going to put a breakpoint here. Okay, so this will generate empty array. It will start from 0. So the first one will be the testing. So I'm restarting. And the other ones will be for training at each loop. Okay, let's continue until here. So the testing has 13 elements. It is 1/10 of the training dataset, and the training one has 122 elements. Why? Because we have already separated it by 10, and at the second loop, you see this time the test data will be not the 0 but the first chunk. Okay, so it is starting with the first chunk as a training, and the second chunk will be the testing, as you can see, and the third chunk will be training, and so on. So basically we are separating data into the chunks, and let's keep the names of the testing and training. LSD testing data file paths. We can make this as tuple, so it will be better. First one will be test, and the second one will be the train and test. Okay, so let's compose. Will be as training dot train plus I plus dot text. Okay, and the test file path will be test I and file write all lines, and training file path will be training and testing. Okay, and we will add it here. Leave tuple as this training and testing. Okay, now we have generated our 10-fold data. This is the lame way. but easier way to show you. This is not the most appropriate way of doing tenfold. Okay, it is done. Now we can see it. Oh, oh, okay. So we have a simple error here. Now the rest is so easy. We will just uh, start 10 tasks. We will await them to finish. I will show you. Okay, training set has generated. Test set has generated. And now we will start tasks. Okay, then we will have model data. This was returning tuple of this. We can make this actually a class. It would be better. Let's make this public. And this will have public double DBL accuracy double mean and activation network IGNet and our prop text equal to this equal to null. Probably we can set it, yeah, and this will return instead of tuple this. So instead of tuple we will say new training, and it will be set like this. Let me show you. Okay, the accuracy will be here. What was the name we have given? IGNet. Why it is not appearing? Oh, we didn't set them public, that is why. Okay, and prop text will be this. Okay, so simply we will have a list of our custom class unfold cross validation results like this. Then inside task factory, start new. I will have task factory inside task factory, so it will run in fully multi-threaded mode. And here I will start another task factory. Here task equal to like this, and this will be in for loop, or for each loop it will still work. And here here. Writing 1, training path, and testing path. I hope this will be, yeah, let's make it like this so it will be more okay. And here I will start my method call. It is here. So it will take training file name and the testing file name, and it will return a model, and I will add this model to this, but I will use locking because it will be running as multi-threaded, and I will add the model, and I will add these tasks to the task list here at VR task, and I will await all tasks here. I think it was join or something. We were using like something, maybe task list. One second. I think I can make, wait. Task.await all. Okay. Task.await all to array. Okay, here. Wait all, and it gets tasks like this. Okay, and once it is done, I need to convert this to array, by the way. What I need to do is simply get the best task and save it. Okay, so I will order this by descending here, and here dot accuracy. Okay, to list, and then save model properties. And model accuracy will be first dot accuracy, iteration will be first dot okay, it doesn't keep the iteration. We don't need to keep the iteration right now, but we can keep it if we want. How can we do that? We can do it like this. Let me show you. Zero and where is the iteration? Equal to I and okay, and now I can use the iteration custom path. Okay, we can provide custom path. We can say 10-fold model dot txt. Also, we can write others to the text file. See them how our each KNN behave it. Append line. Okay, we can't see the file name, so I will need to hold the file name here. And here, the file name will be equal to SR. I think it was here. Now I can use it. You see the program gets bigger and bigger. We should have been using classes and different methods, but I am doing a quick programming right now. File and iteration. Let's say accuracy will be equal to and 2 and iteration will be item dot and 0. And what else there is we can use prop text. Oh, we were already saving the prop text. Oh, okay, but we have still saved, no problem. Okay, this is enough. Let's see our software. So I'm going to set the max iteration count here also. Iteration count will be equal to, by default, let's set it 1 million. Okay. And okay, here. So the for loop will run like this, and if here accuracy equal to 100, break. Okay, so if we can reach the maximum accuracy, we will break it. Okay, now everything is ready. Let's run the application. Now we will train 10 models at the same time, and it will of course use a lot of CPU. I'm going to close this. Okay. One moment. Okay, and let's start. Okay, looks like we have a problem here. Oh, I see. Yeah, the issue is I have to move this into this task because of the task system of the C Sharp. If you watch my object-oriented programming and introduction to programming courses, you will learn much more information related to C Sharp, including these ones. Okay, now the application should be running. Let's continue. Oh, mm, okay. So you see, we need to write the network. Okay, they all try to write the network at the same time. Since they will be using same data. This is not important for us at the moment, by the way. I'm just going to comment this out. When multiple threads tries to write the same file at the same time, of course you will get an error. Okay, you see each one is getting trained right now. Train 10, train 0, train 3. Accuracies are calculated by the separated test data. Okay. All right. So we will use the best model after training of all. You see some of them reached 99% already. However, my computer is having hard time right now to keep it up because it is pretty simple. But if you have a decent new computer, you may easily process all of these at once. Oh, by the way, I will just let them train until 50k iteration, so it will get completed quickly. Here, let's provide 15 max iteration. Let's view the solution. Okay, and let's start without debugging so it will run faster. Okay, now we just need to wait until they reach 50,000 iterations. Okay, so far some of them has reached 10k, 6k, and once they start reaching 50k, those tasks will end. Okay, we are getting close to finish. And your algorithm accuracy would be the average of all 10 of these. When you compare multiple algorithms, you should calculate the at least tenfold cross-validation results and compare each algorithm success rate by comparing tenfold cross-validation result. Okay, average of tenfold cross-validation. So the tenfold cross-validation has ended, and our data is written or not. Okay, probably we had an error somewhere here because I don't see the file. Yeah, we didn't write this, but this should have been written. Say model properties. Why I don't see it? Okay, we have an error somewhere. Hmm, maybe it has, let's sort by date modified. Oh, this is interesting. So it has run until here, and okay, let's make it run until 1000 for more debugging purposes. Once you're sure that your algorithm is working, you can make it run for a longer time, and you can tune your algorithm. At least one object must be implemented. I comparable. Yeah, I see. As you can see, we have provided the network here, and it is incorrect. We need to provide accuracy here. That was our error, and let's build. Also, let's calculate our average accuracy. Zero and not. I can write it like this immediately actually. Okay, 1 second, I will show you. We have provided 10. And then I will split this by count. Yes, this should work. And then I will use some formatting. Okay. Okay. Okay, let's build it. And let's run it without debugging. Yes, the model has generated. We didn't get this written. Mm, West and oh, okay. Let's increase this a bit more because with 1000 it is being too low number. Okay, let's move to solution. Okay, at this lecture, I have shown you everything related to how to build a machine learning model and how to save it and use that saved model on a unseen new data, predict new data. So at the project you are going to make as final exam, I am expecting same results from you. You should apply tenfold cross validation and show me the results. So let's see the old model. Okay, you see some models has failed like this. It didn't get, they didn't get improved. Some models has reached very good numbers, and the best one is this one, 99.18. And now I can use that trained model to check the test the unseen data like this, and we can see the test results. So it has reached 100% accuracy. Okay, for today this is enough. I hope you watch this lecture very carefully and understand it very well, because this was a really important course. I have posted the project announcement on the GitHub and our school LMS system. So this was a great lecture. I mean, the lecture 6 and lecture 7 was extremely useful for you to understand how machine learning is done, how it is complex. And okay, oh, do we have any big file here? Probably not, but yeah. Uh, okay, adding files failed. Why? Hmm. File name is too long. Okay, let's delete the temporary folder because we don't need it. Yeah. So these have two big files, file names. I'm going to delete them. Okay. So the GitHub repository is updated. Let's verify it. Okay. Okay, hopefully see you next week. Try to stay away from coronavirus. Try to stay at home. Okay, hopefully see you.